Hi, this is Adam. This is my first video of Houdini. Here I would like to share some tips that I learned about transfer the shape from one to other by VDB Advect. So let's do it. First thing, I would like to create the geometry node and dive in this node and create a sphere. We use a polygon. A little bit higher frequency, 10 should be fine. Then we created the test geometry, pig head. So in this tutorial, what I would like to do is transfer this sphere shape to the pig head. So we can put them here. What I would like to do is make the sphere bigger to cover this pig head. Okay. So I might lower the position and make it bigger. Yeah. Okay. I fully cover the pig head. I don't need a shader, so just keep it simple as possible. Okay. So the next thing, I will transfer this sphere to the VDB. VDB from polygon. Also check the fill interior. For this case, I use the distant VDB surface, and then we create bounding box from this sphere. But since sphere is the biggest object in this scene, so I use sphere as a bounding box to cover everything inside. Then I use this bounding box to transfer it to the VDB, to the fork VDB, to create the vector field for velocity. So change to the density mode. Also check the fill interior. So right now you can see there is a voxel generated based on this bounding box. Okay. Then I duplicate that node. Do the same thing for the piggy head. You can see we have a piggy head, fork, volume here. The next thing, we use the VDB combine. To combine these two fork together. What I'm doing here, I will use the subtract. Use the first VDB, fork VDB, which come from a bounding box, to subtract the pig head fork. So you can see a little bit here. There's a inside have a lower density than before. Compare with this. But because we subdivide the density of the pig head, so right now inside have less density. So next thing, to create a VDB analysis to convert this gradient to the vector. Then we will use that vector as velocity. So that is not friendly to review what happened there, so we can use a volume trail to review what we got. I use this pig head as guide geometry, then we can see. Okay, here we can see there's vector generated based on the density. And we can change this to the red, black body. And you can see based on that, the velocity, the vector actually point to the interior, to the surface of the piggy head. Because this calculation, it just generated the vector based on the density. When you work on the fork mode, which you use the fork VDB, they always point from a lower density to the higher density. So this we can get like that. And what did we make? Need to make another node, the VDB Advect. Here, put this surface VDB here and point the velocity here. Nothing happened. The reason why is we need a iteration this calculation in every frame. And put this second frame. So actually the solver will do the iteration for each frame and use the previous frame in the current frame calculation. So type in the solver, we need to add the VDB Advect here actually, and use previous frame as a result, and use the second import for the speed, the vector, actually velocity. So check here, so that we will use this node as result. Check it out. Let's play it again. Yeah, that works. But the resolution is not that good. We lost a lot of detail. So to increase the result resolution, what we can do first thing is we can increase the voxel size. The voxel size right now is too low, so if we put it at 0.05, let me see if that is enough. Based on that, 0.05, and also lower this one, 0.05. And if we take a look at that, we can calculate again. Back to the frame. Then you can see we get a much better result. You can keep increase the voxel density, which lower the voxel size to make the more accurate result. Also, you can increase the substeps. That will increase the calculation time. If you put 2, you need to calculate twice for one frame. It will calculate in the 1 frame and 1.5 frame, then for 2 second frame. It will have better result, but definitely cost more time. Also, inside the solver, in the VDB Advect, you can lower the time steps. That will increase the calculation time, but give you better result, more smoothly. So here, some people ask what difference between to use fork density, fork VDB, and distance VDB. Actually, you can use either fork or distance to achieve what you want. The difference is just when you work in the distance VDB, when you calculate the vector from gradient, they always point to the surface. In that case, will be from the interior to the surface of the pig head, because the distance VDB in the attribute surface, it defined the distance to the surface. So it's not same as the fork VDB, the density. In the fork VDB, they always calculate the point from the low density to the higher, so which opposite direction from outside to inside. Here is an example. Here you can see what we use is fork VDB. If we change that to the distance VDB, we just duplicate that node. VDB analysis, then we connect to here, and you can see So you can see right now they all point to the center, from the surface to the center, because on the surface the density is lower density. Can review here. The edge is lower density, and the interior will more high density. So when they calculate based on the gradient, they're always from the low density to high density. So that vector will make, if you use it on the sphere, in this case, it will shrink the sphere to the surface. But if we change to use a distance VDB, it will from the surface to the outside, kind of like a normal map. It's just because the information inside the volume is changed. So if you want something extend, become bigger and bigger, you can just use distant VDB. But either distant VDB or fog VDB can achieve similar result. Here is the example. So if I use the volume wrangler, we need to do some change here to make it work. What I want to do is change the velocity direction. In this wrangler, we just opposite direction of the velocity. I put here. You see, that is very close like the one we use from the fog VDB. We can do the comparison here. Let's duplicate that VDB and we use fog VDB. Then we use another node. Okay. So the left one is use the distance VDB, and the right one use the fog VDB. It's not exactly the same, but you can see it's quite similar. So if you want to use the fog VDB, but you find the direction is not what, it's kind of opposite. You want to go inside or you want to go outside, you find it's not what you want, you can use volume wrangler to change the direction to opposite direction, then to achieve what you want. And since that is mean you can change the velocity before you feed it to the solver or VDB Advect. So here example is you can add noise in this. So let me change it back to the fog VDB. And what I want to add is a volume velocity, or you can use the volume VOP to add the noise inside. You can have a similar result. So here, put it inside the view. We can clearly see what I have in here. Deformate all of velocity we made, the vector we made, add the noise on the top. This can be give you some very interesting result. You can lower down that value, not too much, to give you some result, good result, which you want, but add some variation on the top. Then you can point that back to the solver. To make it work, we need to do another thing. It's inside the VDB analysis, we need to use the customer name, because I want to change the current velocity, the vector we made. We need to have a name here. So we call VL, like what I did before use the volume wrangler. We have to have name, then we can change it. So here the point, we give you that same name, then come back to the beginning, copy it again. Okay, instead shrink from the object to the smaller object, we also can do the opposite way. From small object grow to the another shape, so big object. Let's do it. So we just change this network. First thing is we need to make the sphere smaller, probably 0.5. Let's check out with the piggy head. Yes. Then we don't need that bounding box. What we need is still use a fog VDB density, and also this one, same one, and we need to combine them together. This time we not use subtract, we use add. We add them together. So inside have a more density compare with this one. You see, have more density. Then we do the same thing here. Just to remove that noise. Right now we don't need it. So what looks like right now? See, and the all vector, the velocity point to the center from low to high, and in the center they have a higher velocity. So if we play like that, it will shrink down. It's not what we want. So we add the volume wrangler. And we change the direction opposite direction. So now it should be go outside. Let's try it again. Expand itself and try to fill all this volume, which shaped like a piggy head. Here you can see the sphere didn't extend to the full piggy head. Even we calculate more, it will still leave some area like that empty. The reason why is because when we calculate the vector, it's based on the sphere. But when the sphere extend, we change the shape. So since the shape is kind of complicated, it's not a regular shape like a box. So when we change the shape, we need to recalculate the vector, recalculate where it need to go to fill all of this pig head. So what they need to do is recalculate that in the solver. So type in the solver. We need to use the preview frame geometry to recalculate that. So to do so, back to the top, we don't need that calculated here. We just duplicate that and also combine. We can go like this. We just connect this, the pig head VDB fog, to the second import, and I just copy paste the node what we made outside inside the solver. First thing is we need to convert VDB, because the import, the first import is not fog VDB, it's distance VDB. We need to convert that to the fog VDB. so we better work in the same type. So we convert to the VDB from the SDF to the fork. Yeah. Then we connect this to the VDB combine, and the second one combine here. Then do the same thing here. Connect this to the VDB Advect. Go back here. Oh, need to put this for the output. You need to be very careful sometimes. Sometimes just to make a mistake, click other node as the output, then you didn't get what you want. So back to here, check this, back to the frame, calculate again. Okay, so you can see it works. It feels all piggy head. If you want a better result, you can do the thing we said before, increase the voxel size and do the more subtle step, so we'll get a better result. Okay, that's it. I hope you guys enjoy my first video of Houdini, and I will keep doing that. I will keep sharing any knowledge or tips I learned from it. I can't imagine how can I learn it without so many people sharing the knowledge and information, sample file, video tutorial. So to thank them, I think the better way is sharing what I learned. I'm still a beginner of the Houdini, so I will keep doing that. Let's keep doing that. See you next time.